Today's video is your unit review for your Unit 2 test. I gave this assignment as a homework, and I wanted to go ahead and just do a couple of problems for you from the worksheet, one or two per section. So in problems 1 through 2, they want you to determine if the relation represented below are functions, and they want you to justify your response. I wanted to go over one of these because you're doing a great job on if it's a function or not, but the problem that I'm having is we are not justifying our response. So I just wanted to remind you how you can justify your response. I'm going to go ahead and do question number 1. Since question number 1 is a graph, I'm going to go ahead and do the vertical line test. Now I can show my vertical line test by doing just one vertical line that intersects the graph one or more times. Since it is intersecting the graph in 2 points, there we go, this is not a function. And my justification is with my marking of the picture. Please make sure that you are justifying in some way. A table you could justify by marking the two that are the same number or circling the two x's that repeat. Um, in a set of ordered pairs, it's the same thing. You could start highlighting in different colors, right? This one is a different number from this one. And you could do that in ordered pairs as well to show that you did check them. Or you can write out in words, the X does not repeat, or the X does repeat. All right, moving on to problems 4 and 5. I want to go ahead and do problem number 4. Determine if the situations are functions or functional or not. Now, I know it doesn't tell you to justify your response, but it really does help in your thinking to go ahead and to justify your response, not just saying it's a function or no, it's not a function. All right, a science student created a bacterial culture of a swab from her toilet bowl handle using a petri dish. She recorded the amount of bacteria in the petri dish once each day for 5 days. We're going to grab our highlighter now, and we're going to use our colors for X and Y. Remember, when this question is asked, is the amount of bacteria in the petri dish a function of? This is your Y value. So this is not the one that we're looking to repeat. Of a function of, and now this is the one that we want to look to see if it's repeating. This is our X value. The amount of time it cultures in the petri dish. So normally I would want to say that time can repeat. However, I need to go back and look in this situation. What is the time? Well, we have once each day for 5 days. So I need to really think about, in the 5 days, is that a repeat? No, because we have day 1's data, day 2's data, day 3's data, day 4's data, day 5's data. That is not a repeat. Now, where we can repeat is if we're taking data multiple times on day 1, multiple times in day 2, multiple times in day 3, etc. Since it says right here very clearly, once each day, the days are not repeating. So yes, this is a function. And it's not a bad idea to say why. This helps clarify your thinking. Oh, sorry, it's not a student, it's a scientist. The scientist only took one recording per day. The days are not repeating. We don't have a bunch of days for X1. All right, problems 6 through 11 are asking you to evaluate. I want to go ahead and do problem number 6. Remember that this is the number that you are going to plug in for the x's in the equation. So the first thing you're going to want to do for me is you're going to want to write down what you did in your calculator. This is going to get you optimal points on the test. Um, Once you have gone ahead and plugged it in on your paper, you're going to go ahead and take this part right here and put it into the calculator. And then the calculator is going to give you your answer of negative 43. Yes, my calculator is giving me my answer, but if we can do human error, and if I don't see this part right here written down, if I don't see this written down, then I can't give you any points when you make a calculation error. I also want to go ahead and do question number 9 because a bunch of us on the assignment were not doing question number 9 completely correct. It is just a substitution once again, and so we're going to go ahead and look for our x value of negative 3. We are going to go ahead and find our x value of negative 3 on our graph, which is this point right here. Right, wait. 2, 3, this point right here. And then what I have to do, let me go ahead and zoom in for you, is from that point, hold on, let me just not confuse you here. From this x is negative 3 right here, let me go ahead and put that that's negative 3. I need to move to the graph. So I need to go in an upwards direction till I hit the graph. And in this case, I just went up because my graph was above where x equals negative 3. If my graph had been, let's say, like this, then I would have gone down to the graph. Okay, but I have to go to the graph. That orange dot, that orange yellow dot on my screen is my answer. However, I need the y value of it. So this is my answer right here, which is positive 1. I cannot, my answer is not on the graph. My answer is not a dot on the graph. I actually have to say what my answer is. And this is how I would put my answer for this question. Okay. You're making me an ordered pair is what you're doing. You're giving me the ordered pair for this point right here, and your answer is the y value of that ordered pair. All right, let's move on to the next page. Let me go ahead and zoom out just a bit. I do want to take a look quickly at questions 10 and 11 because these ones seem to confuse us on the last quiz. Notice once again, we're still in the evaluation phase. So even though it says if negative 12 is an element of the domain, it's giving you this number is your x value and you're simply plugging it in. So you're simply going to go ahead and do f of negative 12 equals 6 parentheses 8 minus negative 12. And then you're going to pop that into the calculator to give me an answer. Okay, once again, in the other one, if 2 is an element of the domain of this function, we're just replacing those x values with 2. What's the corresponding element in the range? Both of these are talking about x and y in the domain and range idea. But once again, remember, domain is x, range is y. You're just substituting in. All right, I want to go and move down. Oops, I want to move down to question 14. State the domain and range of the situation. Clark works as a photographer for a newspaper. He always earns $25 per image sold to the newspaper for featured stories. This function right here, f of x equals 25x, represents Clark's earning per featured story given x, the number of photos he sells each story. If the newspaper always purchases at least 7 photos, but no more than 12 photos per featured story, what is the domain and the range of f of x in this situation? Now, I do have to stop just a little bit, and I do have to understand what this x variable is talking about. And in this case, the X that they're talking about are the photos that Clark is selling. When he's selling photos, he's selling at least 7, but no more than 12 photos. So these are going to be my range, my domain numbers. However, I also need to stop and think, can he sell part of a photo? Well, that doesn't make any sense. Who would want to buy part of a photo? And how would you even sell them part of a photo? So he can buy, his domain would be 7, 8, 9, 10, 11, 12. There would be my domain. My range would be the values of these numbers being placed into the function. So 7 times 25, or 175, 8 times 25, 200, 9 times 25, 225, 10 times 25, 250, 11 times 25, 275, and 12 times 25, 300. Squeeze that squiggle in at the end. Is my situation discrete or continuous? It is discrete. And I'm going to explain. It is discrete because I could say the newspaper cannot buy, oops, buy, there we go, parts of a photo. You could also have said that Clark cannot sell parts of photos, or you could simply have said that parts of photos do not make sense. Now, the last page on our review is the page that corresponds to our very last lesson, state the domain and range. I did want to go ahead and do a couple of these just as a quick reminder. So let's take a look at number 16. In number 16, remember you're looking at the left side and you have a wall right here at x is equal to -2. And on your right side, you have another wall here at x is equal to +3. Our domain then is going to be -2 less than x less than 3. Since the circle at -2 is closed, I'm going to go ahead and go back and add the or equal to part to it. Our range at the bottom, I see a floor, right? I see a floor right here at the bottom at y is equal to -3. And my ceiling is all the way up here. It is not here. We don't have a double ceiling. We only have the ceiling at the top, which is at y equals 6. So for my range, I'm going to go ahead and say -3 less than y less than 6. Since my floor is a continuous part and it is going to be closed, so I'm going to say less than or equal to. Since my point at 6 is an open circle, I'm going to leave it as less than. And finally, let's go ahead and take a look at number 20. In something like number 20, remember you want to go ahead and list your domain as all of your x values. So we're going to go ahead and list our domain as our x values of our points. We're going to go ahead and start with the left one, and we're going to end with the right one. So we need to put them in order. So we're going to go point 1, point 2, point 3, point 4, point 5. Those are the ways that we're going to list them, but we're going to list them on their x values. This one is -6, this one is -4, this one is -2, this one is 0, and finally this last one is +2. So I'm going to say -6, comma, -4, comma, -2, comma, 0, comma, 2. I should have 5 of them. Now I'm going to come in here and I'm going to just erase these numbers because that only worked for the domain. Now we're going to go ahead and we're going to do the range. Remember, your range is going from the bottom point to the top point. Now, what I want you to notice here at the top is that you have 2 points that contain the same number. You only put that number at the top once. Spoiler alert, there's another couple of points that share a y value, and so you only put them once as well. Here at the bottom, we're going to go ahead and start at our y value of -4. Both of these two y points can share the y value of -2. So it's almost like I can write -4, -2, another -2. I just went ahead and put it on top of it. Notice how I made it a little bit darker. And then finally, right up here at the top, which is +4. I could do the one on the left and the one on the right. Notice I just made it a little bit darker. I did not put both of them. I really hope this helps. Good luck on your